Analytical geometry is one of those great sections in paper 2 where if you have a good understanding of how to use the formulas, you can actually really achieve great marks. So these are the different formulae that we encounter on our formula sheet. So we don't even have to remember them. We just need to know which one belongs with which. So if they ask us for any kind of length, then we're going to use this distance formula here. Then we've got the midpoint formula, so basically the center of a line segment. And then these two here both refer to m, and m by now we know is the gradient. And then in grade 11 we were introduced to this concept that a line works with an angle of inclination. Okay, and remember, if you have a positive gradient, then you can just work out your angle of inclination. But if you have a negative gradient, then you must first say 180 degrees plus arctan of that gradient. So don't forget, when it comes to inclination, it's just that one little extra bit that we do for negative gradients. Okay, and then these last two here we know so well by now. That's just the equation of a straight line. Okay, and then in grade 12 we learn one more formula. But before we dive into that, I would love to just double check that we understand all of these, we know when to use them and how to use them. So let's dive into a quick example. In the diagram, we have got P, Q, and that's a straight line. Okay, so question 1, calculate the length of PQ. So whenever I see that word length or something to do with distance, I head to the formula sheet and I'm looking for that distance formula. Okay, once I've got that in place, I then just need to decide which one is going to represent point 1 and which one's going to represent point 2. And I think I'm going to do it this way around. Call this point 2 and this point 1. So now all we have to do is substitute in our different coordinates. So the distance here, I always like to say distance of PQ in subscript there, because sometimes we have to work out more than one thing, and then it's definitely helpful to just differentiate which line we're working with or which coordinates we're working with. Okay, so we're going to go x2, which is 5, minus x1, which is minus 4. So minus minus becomes a plus, and that's squared, plus y2, 2, minus y1, which is minus 3. So minus a minus, again, is a plus. There we go. And once I'm at that point, I can really just pop that into my calculator and get an answer. So it's 5 plus 4 squared plus 2 plus 3 squared. And that gives us 106 inside of that root there. And so the answer there is the square root of 106. Okay, if they didn't specifically tell us that we need to leave our answer in surd form, then we need to give 2 decimal places. So 10,30 when we round that off. Okay, and that's units. They haven't specified here if we're working with meters or kilometers or whatever the case is. So we are just going to say units. Okay, next up, they ask for the gradient. So gradient, M, that one, we shouldn't even need to go to our formula sheet. We should know that one so well by now. y2 minus y1, we were introduced to this formula in grade 9. x2 minus x1. Okay, so we again just going to substitute in 2 minus minus 3. So minus minus becomes a plus over 5 minus minus 4. Okay, so what do we end up with? That's going to be 5 over 9. Okay, so there we have it, question 1 and question 2. Now the midpoint, that's also a nice and straightforward question. So we can go and get the midpoint formula from the formula sheet. Right, so once again we are going to be substituting in our points, and this time we are going to add them together. Okay, midpoint means that somewhere between P and Q, there's another point M, and we are going to try and work out that point's coordinates. So we're going to take x1 plus x2, so we're going to say minus 4 plus 5, and that's going to be over 2. And then the next one, the y coordinates, minus 3 plus 2 over 2. Okay, so what do we end up with? A half and minus a half there. Those are the coordinates. So that could be the coordinates there of M. I'm simply using these formulae. I'm going quite quickly through these first ones because I know you've been working on this since you were in grade 10. Okay, now let's determine the equation of this line. So PQ has an equation, and you can actually use either one of the two formulae on your formula sheet, so either y equals mx plus c, or I'm going to opt to use the other one because I always think it's good to practice it. It doesn't get used often enough, in my opinion. Okay, so there it is. Y minus, we need to put the y1's coordinates down there, is equal to m, we worked out the gradient there, was 5 over 9, multiplied by x minus x1's coordinates there, which were 5. Okay, now we're going to multiply that into the bracket there. So we're going to have y minus 2 is equal to 5 over 9x minus 25 over 9. And then we're going to put this minus 2 across. It's going to become plus 2 when we get to the other side. And then we can add some like terms together, and we'll have a final equation here. Y equals 5 over 9x plus minus 7 over 9 once we've added this minus 25 over 9 and 2. Okay, and then finally, a recap of our grade 11 concept that we learned, and that was all about inclination. So the size there of theta. So if you look, theta is the line, or is the angle formed between the x-axis and my straight line there. Okay, so I write down that formula, 5. Okay, tan of theta is equal to the gradient. Now, fortunately, I've already worked out the gradient there in question 2. So I can literally say, well, tan theta then is equal to 5 over 9. And if I want theta, I'm going to use the shift button on my calculator to get arctan of 5 over 9. Let's see what that's going to equal to. So on the calculator, shift tan 5 over 9. And we get an answer there of 29,054. So 29,05 degrees. All right, that was a very quick flashback. Everything we should know by now. And remember, it's all on your formula sheet. But if you don't know which formula to use when, then you're not going to get the marks. Okay. Now, let's take a look at the grade 12 formula that we get introduced to. And it links here to the equation of a circle. So on the Cartesian plane, we can put a circle. I've called this a circle with center C. And the equation of the circle is this. X minus a squared plus y minus b squared is equal to r squared. Right, now what we need to figure out is what each of these letters represent. So we've got a, we've got b, and we've got r. Okay, x and y, they always form part of every equation on the Cartesian plane. So don't worry too much about them. All right, this center here, C, has the coordinates a and b. So that's the first thing to know, is that a and b in your equation are the coordinates of the center. Okay, the x coordinate goes with the x, the y coordinate goes with y. Be very careful. Do you see how the equation has a negative sign in it? So we would actually be changing the signs of these, but you'll start to see that as we do more and more examples. And then r, in this case it's r squared, is the radius of the circle. So basically the length from the center to the circumference. Okay, so that's the equation of the circle. Let's have a look and see if we are able to tackle questions based on this concept. Okay, here are some examples for us to try. Write down the coordinates of the center C and the radius R for the following. Okay, and then we've got 1, 2, 3 equations of circles here. Let's quickly get that equation up so that we can refresh our memory as to what exactly we are looking for. Okay, so the equation says x minus a, y minus b, squared, is equal to r squared. So I check first, is this in the standard form? Do I have x and something in a bracket, y and something in a bracket, equal to something? And I do. This first one is nice and straightforward. So what I want to do is I want to look at this coordinate, and essentially the square root of that in order to give me the radius there. So I'm literally just interpreting the equation now that it is the equation of a specific circle. Okay, so the center would be, and remember to change the sign now because it was minus a, so minus 2 would give me that positive 2 there. So the x coordinate is minus 2. Okay, then minus 3, that's fine. We can just take the 3 there. And the radius is equal to, well, this side is r squared. So what's the square root of 25? It is 5 units. Okay, and a length, like a radius, is always going to be positive. So generally when we square root something, it's plus or minus. But in this instance, we know it's a length of a radius, so it's just 5 units. Okay, the second example here, let's have a look. We are looking for something there with my x, something with the y, and then the square root of whatever's happening there. Okay, there's a bit of a problem here because there's nothing with the y. Okay, but remember in maths, we do actually know that nothing means plus 0. So don't panic too much when you see that. You can still answer this question. So here we can see the center is going to be 5, it's always the opposite side, and 0, and the radius is equal to the square root of 12 units because this was r squared. Okay, and then finally, this last one here is just a big fat mess. Okay, it's not in the right format. Okay, and so we need to go back to our knowledge that we gained in grade 11, and we need to complete the square. Okay, let's try and refresh our memories as to how exactly we do that. The first thing I do is I put all of the x's together. So we're going to say x squared minus 10x, then plus y squared plus 2y equals 4. All the constants, we want them to go to the right-hand side. Okay, now we want to form our two brackets. We want a bracket here with the x's, and then a bracket here with the y's. Okay, so let's figure out exactly how we would square that. Okay, so when we were completing the square, we used to take x times x is x squared, and then we would take half of this coefficient here. We used to call this b. So half of b would complete that square there. So minus 5. Okay, but then if you can remember back to grade 11 when we were first introduced to this, let's do it over here just to refresh our memory. What happened was when we would square that out, we'd end up with x squared minus 10x plus 25. So what we've done by completing the square is accidentally added a 25. And so because we've got an equation here, we can just maintain the principle that if I add it to the one side, I have to add it to the other side. Okay, now we're going to do the same thing with y. So y times y is y squared plus half of the coefficient of b. So half of 2, which is 1. Okay, so what do? We accidentally added, in this case, we accidentally added minus 5 squared. So, or accidentally, we technically did it on purpose, but we just need to make sure we're balancing the scales here. So on this side, we've added an extra 1 times 1. And so what we do to the one side, we need to do to the other side. So we need to add an extra plus 1. Okay, if you want to check it, you're welcome. Take this out here and do a little bit of FOIL. You will see there you end up with y squared plus 2y plus 1 when you expand this bracket. Okay, so let's quickly have a look. What are we sitting with now? This is starting to look like the equation of a circle. X minus 5 squared plus y plus 1 squared is equal to 4 plus 25 plus 1, which is going to give us 30. Okay, and that is fantastic because have a look now. I've got an x and a y coordinate of my center, and if I square root that, I can get the radius length. So let's do that. So the center is going to be 5 and minus 1, okay, because minus 1 would give me that positive there. And then the radius is going to equal to the root of 30. Okay, so when it comes to this section of analytical, please make sure that your memory is fresh on how to complete the square, because it is an invaluable skill to have.